you all. Thomas, if you'd like to say a word, and then I can start as well.
Yeah, so this is a session mostly Dr. Rami Riman is going to be giving. I'm here mostly for moral support, but he's talking about some very exciting new solutions and services that the healthcare team is going to be rolling out and talking about. And for me, it's particularly exciting because we have great product for EMR in our TrakCare product outside of the US. As well, they're working with customers that are using HealthShare and providing very useful tools around that and teaching our customers how to take advantage of their data, use it in different ways, gain insights, do machine learning. So I'm very excited about this presentation. And so with that, I'll pass it off to Dr. Riman, and you'll need to introduce yourself a bit.
I will.
Yeah,
I will. Thank you,
absolutely.
Thomas. So thank you all for being with me today. I know it's difficult, 4:30 in the afternoon, and you'll probably forget my name in 2 minutes. I'm Rami. I'm a physician by background. I'm an oncologist by profession. I was privileged to work between the US, UK, Lebanon, and Dubai, and recently with InterSystems for the last 7 years. I still say recently. And I work as a clinician exec, and we run after the clinical executive team, and I'm responsible for the Europe, Middle East, and Africa region. So in our line of work, one of the key things that I work on is how well do people adopt our solutions, no matter what it is. For me, the practical aspect is what's most important. There are technologies that are very nice. There are things that we spoke about for 3 years, 4 years. But for me, it's the outcome and how does that impact the end user is of extreme importance, basically from a bias because I'm a clinician, but also for the well-being or the outcome or the value that we could drive from our solutions. So that's me. I was debating which story to tell, but I will go with this one. This is one that started why I do what I do and the things that we have created using AI in our technologies. So why, the question here is we have a 37-year-old lady, Mrs. H. By the way, she's my cousin. And she got hospitalized in 2021 for 6 days for an acute kidney disease. She's healthy, she's fine, but she had an acute renal failure incident in 2021 around March time. So to walk you through what happened, in February 2021, she had a tooth problem. She went to the dentist. And at the dentist at that time, she's done a surgery, she's done well. She was given a course of antibiotic, broad spectrum, amoxicillin. She did well, she went back home, life is good. 10 days later, she had a sore throat, she wasn't feeling so good, went to the GP. At the GP at that time, identified that she's having an infection and was prescribed another course of antibiotic for which she did very well, and she recovered, and life went on. 3 weeks after that, it was around the mid of March, she started coughing. Her fever started to rise. She was having a severe upper respiratory tract infection, and she was sick again. She went to the ER this time. And in the emergency department at that case, they saw her, they prescribed another antibiotic, and they discharged her, and she went back home. 3 days after that, she wasn't doing well, she wasn't recovering well, she wasn't responding to the antibiotic, and she came back to the emergency. At that time, luckily we do have a health information exchange in Dubai, and it was there. The doctor looked through it a little bit more, noticed more the history. She was a little bit more cautious to pass over the history, and the doctor suspected at that time that she might be having an antibiotic resistance. So he said, let's admit you to the hospital, let's start you on Meronam, which is a strong antibiotic for people who don't know the clinical terminology. And she was admitted, unfortunately, due to the courses that she has had, and for some reason with the strong antibiotic, she's had an acute kidney injury and her creatinine starting shooting up. She ended up being monitored closely in the ICU. She had a good recovery, I would say, but she suffered from that 6 days of acute renal failure. I hate that incident personally, not for anything, but her kids stayed at my house for those 6 days, and it was a little bit annoying. On another hand, it was quite annoying. And the other piece, it was we created the health information exchange over there, and that other hospital uses our TrakCare as well. And I know for sure that the data was sitting in all of them, yet it was missed by 3 physicians before it was diagnosed. This is true. This has happened, and this can happen every single day in every single place. So speaking of that, and with what I currently do in my role and my job and with the team that we have, we typically fix healthcare problems. So we do whatever we do, you do whatever you do to fix healthcare problems, to fix problems that we have every single day. So these kind of problems, when we talk about them, you talk about clinical problems. If you take a simple problem, you talk about medication error. Now these are like simple problems that you could solve within a simple EMR, but then you start looking further into overdue misuse of medication, going beyond the specific organization, or even further to like things like antibiotic resistance, and trying to collect data, learn from it, do a logic in order to understand where that resistance or when that resistance is going to happen. We look at public health problems. Take diabetes, for example. So today, everyone treats diabetes quite well. We know it quite well. We give the treatment, we give the education, we place the patient on the best regimen possible, yet your number of diabetes cases every single year are increasing. We have a lot of comorbidities that are happening because of that, and we're not seeing any improvement. So we look at how can we do better surveillance, how can we connect that care across the board a little bit better. We look at readmissions and how can we avoid that, because it has a huge impact financially as well as clinically on the patient. Then we also look at ecosystem problems, resource problems. So resource is a big problem. I think that's all across the world. We don't have enough doctors, we don't have enough nurses. We want to know where to put our resources. We want to understand, and one example in France, we had 2 PET scans within 20-kilometer distance under the same organization. Both of them are utilized at 50%. So these are a kind of problems we commonly see. We look at finance problems. So even when the governments are paying for the services, they want to cut costs. When the payers are paying, they want to cut costs. When the hospital is looking for finances, they want to cut costs. We want to look at oversupply, undersupply, and again, all from that perspective of a hospital or a health information exchange. And then research data became very important. And we have new regulations that are coming in order to use this data in a better way and make it readily available, and patient engagement and getting them in. So we've looked at all of these problems. We've used our technology. And one of the ways that we try to solve these problems is what we're talking about today, which is our healthcare solutions using AI. So when we call it a solution, the difference is that we're closing the loop. We're making sure that whatever we build is impacting a specific problem and closing it. And we're not asking organizations to go invest and do the whole thing on their own. It's simply taking a logic that's working, apply it, and be able to start using it today, instead of having to wait a whole year before they can use it. So that's what we have been proposing using our technology. We take our IRIS database. We've built it from our source. We had a model training. I'll talk you through the steps of what we have done. Then we worked on the output, making sure that trigger through a CDS hook, API, whatever way that you want to connect that output back to the user. But then most importantly is the monitoring. We wanted to make sure that the logic is constantly viable and active every time we retrain. We also wanted to monitor the usage of that output in real life and how well they came out. So every use case that we've built, we've looked at it from the same perspective. We've looked at it from the same standards, and we've built it the same way. This is a schematic of how we've created what we've created. So we've had that source, which is TrakCare or HealthShare. From it, we've taken in the data elements that are the raw data into an IRIS layer. In IRIS, we had the embedded Python with their libraries. We've ran the different experiments. We visualized those experiments into our analytics tool. And when we were happy with the outcome, we made sure we sent back that outcome to the source. That's how it is. It's all sitting within one instance of InterSystems IRIS. And no matter where your sources are, this is how we have located it. The steps we have done, typical of creating a logic in order to be scientific around it. So as I said before, we started off with the data set creation. We've identified targets and non-targets. We've looked at balancing that data set, making sure that this is a good data set. We've done like exhaustive selection if needed. And once we had that data set available, we went to the second step, which is the model training. So we've used standards in the industry. We've done 3 different training sessions or experiments for each of the cases that we have done. Sometimes we experimented more. And then we've used all the standards that you're familiar with, logistic regression, random forest, et cetera. And then we've also done survival analysis when it came to diabetes, as you will see in a bit. And then we've left certain amount of data in order to be transparent for testing. So in every example that we have done, here, for example, we've done things for 2018, 2019, 2020. We left 2021 data for testing, or 2022 data for testing. And then we gave the full data around it for a proper medical audit if needed in order to verify the real value of such a data or such a logic when it is applied. And once we were done with all of this and we were happy with it, this is an example that you will see from our EMR. We created like what we call a feature in the background that's calling that logic, or you can have it in a CDS hook, as I said before. And basically in this screen, when the doctor is saying for readmission, for example, this patient is good to go home. They are healthy, I can send them home later on today. We're sending that computation and we're showing it for the clinician with the likelihood of it being readmitted within 30 days of that procedure. So what cases have we done? How well did we do, basically? So what we're gonna go through the next scenarios are ones that we have done and that we have an outcome for, and I would like to share with you some of those outcomes that we have done. So in this case, we've looked at the 30-day readmission for the same problem. This is a common problem worldwide. Financially speaking, insurance companies can give a discount up to 50% for those readmissions. Clinically speaking, it's a big impact on the patient, on the overall well-being, on their families, on their jobs, et cetera. This is an example of a dashboard within the TrakCare where we had seen the numbers day after the other when the logic is working, where you can drill down and see the exact details. And then when we finished this study, we've ran this on data from 2021 in this case. We've identified those 44%, but we've looked at them from a perspective of, if we knew this data, could we avoid the readmission? What actions could we do to avoid readmissions? Some of the cases had blood transfusion that wasn't correctly indicated. Some had a length of stay in the hospital beyond the normal. Some had comorbidities that were unseen, basically. The true value came at 8%. So when we talk about 8% of your cases in an inpatient scenario that are confirmed to be avoided for a readmission, this hospital does 5,000 inpatients per year. The 8% of it is 400 inpatients that we're talking about. And from a materialistic perspective, if you're just looking at it financially, the amount of savings of that one was 5 million dirhams, which is around $1.25 million, just of those 8% that were avoided to be coming to that hospital. We went ahead with DRG. I'm sure for the US-based customers, you know DRGs. Some places in Europe, we don't use DRG. In the Middle East, we use DRG basic. So in the DRG, what do? We look at the case. We send diagnosis, CPTs, procedures, length of stay, data of the patient, goes to a grouper, comes back and tells you, okay, this is a code, this is a multiplier, and this is the amount of money you're gonna get. What we analyzed is there any anomaly that we are missing from that data shared? Do we have patients with the same DRG codes that could have an anomaly and thus go for a different DRG code? Are we wrong in that? And indeed, that was the case. So we've done that, we've run it out, we've looked at the DRG discrepancies that are available, and then when we did the study of the impact of it, because that's an important piece, we had 20% of the DRG cases with a potential discrepancy. And in that facility, 60% of the bills are DRG based. So that's a 12% of a total financial impact. I don't have the number of the RA, the amount of money they got back from the insurances, so I cannot put a value around it. But 12% is the number of discrepancies that were identified in that case. Then we go to the one that's close to my heart, which is the antibiotic resistance, because I don't like babysitting, and I'm not going to do that again. So in this case, with the antibiotic resistance, we've looked at 70 data elements from the file. We were extensive because our data set was so small that we couldn't afford not to go deep into the data. So we've looked at antibiotics that were given within the last year and a half, the duration of those antibiotics, the resistances that came in from the lab, that's structured microbiology data that's coming from our lab. We've looked at comorbidities, treatments, antibiotics, and after all of those, even with a very, very limited set of data for an AI, we were successful in being able to produce a model that is there. This is not live yet, because as I said, we need a very clean and good data set in order to be able to build it. But this is something the Dubai Health Authority are looking at on a nation level to be able to use and predict antibiotic resistance for the whole area. Then we've looked at diabetes. So again, I was talking to you at the beginning around diabetes. So we put programs. You go tell someone, listen, you're going to have to exercise and eat well and watch out your sugars, etc. And you just don't care about it. Even as doctors, we don't care about it. We talk about smoking, and then you see the doctor smoking downstairs. This is how things work. But when you look at the whole population, when you look at people who are healthy today, and over a period of 5 years, predicting how likely they will become diabetic. Those last 9 patients out of 24 are having more than 85% chance to become diabetic compared to the rest. So if you have a program, if you're going to put an effort to call these people, to put them on a preventative care measure, these are your patients. These are the people we need to focus on, so that, again, we can divert our resources in the right place so that we can get the right outcome out of it. This logic, by the way, is 2 logics. One of them is survival for what I just showed you, but there's also the classical one to see diabetic patients and how likely they are to deteriorate within the next couple of years, looking at HbA1cs, looking at their trends, BMIs, comorbidities, eye, retina problems, vein problems, skin diseases, etc. Then we looked at clinic no-show. This example is very nice. We have a hospital that takes 1,000 appointments every single day. It's a tertiary hospital. They only do eye surgery. It's an ophthalmic hospital only. They have, in some days, 40% clinic no-show in their clinics. So if you can imagine a place where you get people booked 400 kilometers away, it's one center of excellence that they have. They have top doctors, top nurses, top clinicians waiting to see those patients, and those patients don't show up. They had a big problem over there. They were innovative over the last couple of years. We've put all sorts of rules for them. We've double booked their schedules, etc. Whatever you could think of, we've put it in. Until half of the days, on Monday, they overbooked their clinic, and then everyone decided to show up. And it's a problem, because you had people who are not happy, doctors who are not happy, and nurses who are not happy, and it's a disaster. So we should do better. And this is what we have done. We've taken our AI logic. We've studied 110,000 appointments. We've learned how likely people will not show up. We got a 65% accuracy of predicting that. And I'll walk you through what we've done. So typical case, they had a 50-50 chance of not showing up. Their current system, before we implemented what we have done, was that they would call 500 of those 1,000 patients every day. They had 4 people sitting down on the phone call, calling 500 patients every day. We reduced that to 150 patients who are top in the list of not showing up. So that immediately reduced the amount of calls. They picked up 30 out of those 150 started showing up. It worked on them. Now, the second thing that they have done, they decided 30% of that high predictions, we're going to overbook. So they were smart about the cases that they want to book. We put an icon for them on the list so you could easily identify those slots when you're booking, and then the call center can easily overbook that specific case. And they added 50 appointments every single day. So in total, we gave them 80 appointments every single day that are guaranteed compared to what they had before. they had saved 25 hours of work that was lost every single day. So this was done in a matter of 3 months. This customer is going to produce a paper this summer, and these are some of their numbers that they were done before. So in general, people ask, how can I trust AI? And being a scientific person or working from medicine perspective, I need facts, I need things in front of me, and that's how we thought about it. We wanted it to be very transparent. We always learn from the data of that organization. So even when we have the logic, we retrain on that data from that customer just to make sure we are okay. Then we only offer this as a clinical decision support, and we ask the clinicians to embed it within their workflows without disruption, without hard stops, without taking them away from what they want to do. We bring it forward to make sure it doesn't bother, yet it is very helpful, and it can help them to do the output that they want. And then most importantly, because we own the full set within us, we could produce the reasons why the AI predicted what it predicted. So there's no black boxes. If someone wants to know why is this at 90%, we have the answer. And in some cases for the readmission, we routed them or bringing it over to the front-end user to know why is this being done. So basically, our recipe was very simple. Let's take these cases, make sure we have them, and this is exactly what we have done. When they saw the first case working, the pipeline for each one of these customers is a huge now, and we're looking at implementing the third case and the fourth case and the fifth case for each one of them in order to proceed. Now, on top of that, from a business perspective, if you tell someone, take Iris instance, go build your own logic and get in the data, get your data scientist in order to create it and go create it. If you're a company that builds AI, perfect. That's your technology. But if you're a hospital where you don't even have capacity enough, you don't even have the right resources to do this, you want something and you want the answer straight away. And that's exactly what we've done by providing this as a service. So what we have done is, and this is an example of 3 models. Option 3 is the typical traditional model where you have the data scientist, you have enough resources, you take the technology, you take the license, we help you build it, and it's yours, you go run it. The middle option, option number 2, is basically on your own premises where you have your solution, your health share or your TrakCare. We install the Iris, we build the cases for you, and we maintain and run your cases for a period that we have agreed to run it for you. So our team will take care of retraining, of making sure it's still valid, of making sure that the output is still okay, and you just take a subscription. From a cost effectiveness or from a business perspective, this is an optimum answer for people who don't have the resources to do it, and they can start using it in as short as 3-month period, and they could start using it. And then option number 1 is still theoretical to look at the legalities of it and the compliance around it, is that taking the, Todd is happy over there, and looking at the legalities around pooling data into one cloud. We have our own clouds where we have deployed TrakCare, but pooling data from different accounts, we need to make sure the legalities are okay, GDPR is acceptable, compliance is okay before we could do it. So that's still not on the table. But this middle one is our model that we were successful to put in. Under subscription, the customers will pay for exactly what they need to pay for, and they get the value, and that's the most important thing. So that's how we achieved what we achieved. And what we usually look at is, and the main message in here is that you don't always need to wait to get an answer. All of what we're talking about could be doable. Analytics is doable, AI is doable. The question is how long is gonna take you to reach to your goal that you wanna take. And this is why we call it time to take action, because we could do things today without having to wait much longer to achieve the success we wanna achieve. So that's enough of me. Thank you all for listening. And if you have any questions, please go ahead.
Any questions?
Came back with the DRG.
For the DRG.
The use case was you were trying to find whether the DRG was right or not based on something that didn't follow a particular pattern. But doesn't the coder take all the procedures and diagnosis and come back with it? how could it get that wrong unless you're not putting certain procedures or DRG? How could that get wrong also? I mean, how does that happen?
So basically, this was specifically looking at missed coding from the very beginning in the file that was missed by the coder, and then it didn't go to the 3M properly. So it's reviewing a whole medical record file and checking the notes, for example, of the patient. And then you're figuring out, one of the common examples was blood transfusion. So blood transfusion comes in with a specific code, like specific CPT, and that specific CPT does impact your DRG, for example. Many times the doctor says, I want to transfuse 4 units of blood. One of them is there, the other 3 units, they didn't put them in, and the nurses continued their work, and they transfused this to the patient. So it was missed, basically. And that's the anomaly that was picked up. The other one was the comorbidities. So we pick up the diagnosis of the comorbidities, but SNOMED terminology for the problems of the comorbidities, if they did not correlate as secondary diagnosis, is another one that was missed. If you go in by standard nursing orders, so nursing orders, for example, you say ambulate the patient, or let's take a wound management. A patient post-surgery, you want to do wound management. And that wound management, you ask for a specific practice to do it. Now, some of them are not coded and not chargeable, but some of them are. And those ones are the typical numbers that are missed. Dietitian services, this is from our data set. Different organizations might have different, but that's what we were looking for. Looking through the file and making sure where did we see anomalies in comparison to people with the same DRGs, and then identifying those. So that's as simple as it is in terms of finding it. We're not touching the DRG. We're not touching the coders.
They're basically bad inputs for human error. Not enough inputs into the coder, like the comobility, for example, that wasn't inputted, so that you didn't get the right DRG. So they were basically, you were finding human error in the process.
Yes.
Okay.
Yes. And then we put this dashboard for them. So people who do claims, they usually do batch claiming for insurances. So they look at the dashboard before they do the claim, and they figure out, okay, Cigna is having a large number of errors within this batch that we're gonna do. So before you submit the first time for your claims, they go review, make sure they have it, do a recoding if needed, and then they submit. The aim of this one is to reduce your number, the first time rejection of your claims, and then the second one is to make sure also you get the right codes and you're not missing any codes within your coding. The only addition to that case that we started looking at is using NLP, natural language processing, to take even free text and like notes in order to enhance this logic, but that's coming in next for us.
So what if you're an Epic health system? Can you integrate the Epic Iris ODB and provide the AI services on top of that?
Sorry, I'm not hearing well from where I am, so I can go down and hear you better.
No problem. So what if it's an Epic health system and they're using obviously your Iris ODB in their application? Can you layer your AI engine alongside of it and integrate it yourself with the Epic's Iris ODB?
So the source of data does not matter. In this case, we've used our data because this is what we do. But let's say it's Epic, Cerner, Allscripts, whatever it is. All what I needed is that raw data elements, the identifying what data do I want. Once it's in the Iris database, that's the place where we work it. We do all of that, and then making sure that API or the connection back to the source is already done in order to close it. So all of the work is done basically outside. Now in the processes of Iris as well, we've also split the training from the action in order to maintain our flexibility to retrain whenever we want to retrain without impacting the logic, and the logic will always be connected to live and only updated when it needs to be updated. So we can constantly keep retraining without performance impact, and also whenever we send the message and back, it takes seconds only, like literally 1 or 2 seconds to get the answer back, rather than having to go train and then bring back the answer back. So this is how we've done it.
Yeah, but specifically to your point about just using the data that's inside Epic as it is, that's not what we do. You'd have to get it out.
You'll have to extract, exactly.
Wouldn't it be nice?
Any other?
Great. Well, thanks so much, everyone, for your
Thank you
attention.
all.